Okay, this video is on bonding. Finally in chemistry, we are getting to bonding, where we combine different elements together. We're going to start off talking about ionic bonding, which is bonding between a metal and a nonmetal. Well, what do we mean by metals and nonmetals? Let's look at the periodic table. If we split the periodic table, if you look at the periodic table that's on the wall in the classroom, you're going to see a stair-step line. It's red, it's dark red on the right side of the periodic table. And that stair-step is actually separating the metals from the nonmetals. And here we see on the slide that I've actually taken and separated the periodic table. Now, on the periodic table you have in your reference materials, it's just a dark, bold line. And all those elements that are on the left of that stair step are metals, and all of those on the right of the stair step are nonmetals. And here you see in the picture the medium, like blue-green elements are separated from the neon green elements, metals and nonmetals. And that's what an ionic bond is. It's a bond between a metal and a nonmetal. Now, if we take a sample element from the metal side, let's take sodium, and an example from the nonmetal side, and that would be chlorine. Let's look at their electrons. Well, sodium is in group 1, so we know it has one valence electron, and we see that here, the one electron in the outer shell, as opposed to chlorine, which is in group 7, indicating that it has 7 valence electrons. Now let's remember the magic number. All atoms want to have how many electrons in their outer shell? 8. The magic number is 8. So if sodium can just give up this one electron, look at the shell underneath. It has 8 electrons, so it'd be happy. And if chlorine could just gain one electron to put right here, then it would have 8, and it would also be happy. And this is one of the trends we talked about in the periodic table. Chlorine is highly electronegative, which means it attracts and can take electrons from other elements. And sodium is low electronegative, so it does not take electrons from other elements. So what's going to happen in this situation is sodium is actually going to give up its electron, and it's going to donate it to chlorine. Now, sodium is happy and chlorine is happy. Well, what's happening to the element? Well, what we do is we create cations and anions. And a cation is a metal that's given up an electron, so now it has a positive 1 charge because it gave up 1 electron. And chlorine, since it gained that electron, and electrons are negative, it now has a negative 1 charge. Okay, so let's look at a closer look at that. Sodium is atomic number 11 on the periodic table. That means it has 11 protons in its nucleus. Now, we're not changing the nucleus, we're just talking about electrons that are being donated. So that number is going to stay the same. Okay, so after it donates the electron, it now only has 10 electrons. It has 2 in the first shell and 8 in the second shell, so that's 10. So if we take the difference between these numbers, 11 and 10, negative 10, negative being the negative electrons, we see that it has a positive 1 charge. And the same thing happens with chlorine. It's atomic number 17, so it has 17 protons, but it's taken an electron, so now it has 18 electrons. And the difference between a positive 17 and a negative 18 is a negative 1. Okay, so you want to write these vocabulary words down. A cation is a positively charged metal, and an anion is a negatively charged nonmetal. Okay, and what do we know about positive and negative charges? They're highly attractive. So this sodium with the positive 1 charge is highly attracted to this chlorine with a negative charge, and so they bond together to form what we call a salt. So all bonds between cations and anions are called salts, and therefore all ionic bonds are salts. Now we may recognize this salt, NaCl, sodium chloride. This is common table salt. Okay, so this is where we get the idea of oxidation numbers. Now remember, let's look at the periodic table and let's go across. Now you know that valence electrons are 1, 2, 3, 4, 5, 6, 7, 8. Well, now we're going to add some more numbers there, but these aren't typically shown on the periodic table. These you have to remember. So oxidation numbers are used in bonding. In this first column, now remember, we just talked about sodium giving up an electron and becoming a positive 1 charge because it has 1 valence electron. Well, this group here has 2 valence electrons. So is it easier to give up 2 or to gain 6? It's easier to give up 2. So when it gives up those 2, its oxidation number is going to be a positive 2. Okay, and now going over to boron here. Boron has 3 valence electrons. So is it easier to give up 3 or to gain 8? It's easier to give up 3. So when it gives up 3, it has a positive 3 charge. Now we come to a group that carbon is in, and that's a different situation. These don't bond very often in ionic bonding, and it has 4 valence electrons, so it can either gain 4 or lose 4. It's in the middle, so we call that a plus or minus 4. Then we get over to nitrogen. Okay, nitrogen will gain 3 electrons. Okay, so it's a negative 3. Oxygen will gain 2 electrons, so its oxidation number is negative 2. And fluorine, this group will gain 1 electron, so its oxidation number is negative 1. So you just have to remember, on bonding, ionic bonding, the oxidation numbers go 1, 2, 3, plus or minus 4, then back down negative 3, negative 2, negative 1. We're not going to worry about the noble gases. Why? Because they already have 8 electrons in their outer shell, and they typically don't get involved in any type of bonding because of the 8 electrons. They're happy as it is. Okay, so let's look at an example here back at sodium chloride. Okay, we see here that the positive 1 charge balances out with the negative 1 charge. So this combines in a 1-to-1 ratio. But that's not always the case. Let's say instead of chlorine, the sodium was going to bond with nitrogen. Well, the oxidation number of sodium is a +1. The oxidation number of nitrogen is a negative 3. So if these were to bond together, it's not going to bond in a 1-to-1 ratio because we have a positive 1 charge on the cation and a negative 3 charge on the anion. And that's got to balance out. It's got to be just as many positive charges as negative charges in the formula. So how do we solve that problem? Well, what happens is we add 2 more sodiums. Now, this cation total charge is a +1, +2, +3 on the cation side, and on the anion side, that's balanced out with a negative 3. So when these get together, the overall charge is neutral. +3 on this side, negative 3 on this side. So the formula for sodium nitride is going to be Na3, and it's a subscript N, and there's just one of them. We typically don't write this one, so we're going to leave that out. Okay, now another way you could do this is what we call the crisscross method. We write the cation and the anion, and then we crisscross the numbers on the charge. So for example, we're going to take the 3, we're going to cross cross it down to the sodium. Then we're going to take the one on the sodium, we're going to cross it down to the nitrogen. Okay, and this is called the crisscross method. When we do that, we get the same formula as we had before, Na3N. Okay, and remember, we don't write this one because just the symbol for it tells us that there's already one there. Okay, so here's another example. This time I want to pause the video here and I want you to tell me what the correct formula is going to be. Remember, if we have a +3 on this side, we have to balance that with a -3 on this side. So you can use either method you want. Okay, so on the formula, if you said AlCl3, then you would be correct, because we need three negative ones to balance out the +3 here. Or we could simply just do the crisscross. Take this 3, cross it over to the chlorine, and then take this 1 and cross it over to the aluminum. But remember, we don't write the 1. When we put them together, it's AlCl3.